6, Circular and Periodic Functions, Day 2. Let's take a look at finding the exact values for all these expressions. So notice that all of these say cosine, and remember cosine represents the x-coordinate. So for this point location right here, the x-coordinate, remember, is the length of the long leg. So this is going to be root 3 over 2. So this answer will be root 3 over 2. And 5 pi 6 is over here. Remember, it is the x-coordinate, which is the same as this x-coordinate, except it's negative. Negative root 3 over 2. So this will be equal to negative root 3 over 2. And 7 pi 6, again, same triangle. The x-coordinate will be negative as well. So this will be negative root 3 over 2. And over here, this is the x-coordinate. Again, it's the long leg, root 3 over 2 because it's positive, root 3 over 2. Now this is 13 pi 6, so we've gone all the way around, which is 12 pi 6, and then we go up another pi 6. So now we're starting to repeat, root 3 over 2. And again, 17 pi 6 is right over here. So this will be negative root 3 over 2. So they are starting to repeat. Okay, so what I've done is I've went ahead and I've done the cosine in each case. So for each location point, I have just found the x-coordinate right here. And as I went over here to 2 pi thirds, you can see the x-coordinate was negative, negative. It got a little longer, and then over here the x-coordinate was very long, and I went all the way around here. So these are all the values. This is acting like a function. You give me an angle, I give you an output. Give me an angle, I get an output. Okay, so the same thing is happening with the sine as well. But we are looking at verticals. Okay, so over here at 1, 0, the y-coordinate is 0. Right here, this is the y-coordinate. It is the short leg, which is 1/2. This is 45, 45, 90, or pi fourths, root 2 over 2. This is the longer leg, root 3 over 2. And then again, the y-coordinate, which is 1. And then it goes down, root 2 over 2, 1/2. And then the y-coordinate here is 0. And then if we continue with the y-coordinate here, this will be negative 1/2, negative root 2 over 2. It's getting longer each time in the negative direction. And right here, the y-coordinate is at its longest, negative 1. And then it starts to shorten by following this pattern. And finally, when it gets to 2 pi, the y-coordinate is 0. It's important to be able to do all this because right now, we're going to take all these points that we've been doing and we're now going to graph them. Okay, so 0, 0, it'll be right here. And this is pi halves, so I'm just going to read pi halves. I know it's growing, and at pi halves, the y-coordinate is 1. And remember, it's growing like that. And over here at pi, the sign is 0, and that's because the value of the y's got smaller and smaller, so it looks like this. And then here at 3 pi halves, it's over here at negative 1, and all these values are values that got more and more negative. And then over here, these are all negative values, and at 2 pi, it's going to be 0, and these values get closer and closer to 0. So here's what the graph looks like. And then again, going around the circle again, it's going to go up until it gets to 3 pi halves, and then it's going to go down to negative 1 and then go up. And the same thing will happen over here. It'll go down up here, and then the look will look like this. This will be the low point right here, and then it'll go up. And so this period is 2 pi. It takes 2 pi, and that makes sense because 2 pi is a whole revolution around the unit circle. So that makes a lot of sense. Okay, here is cosine. Now cosine starts at this thing is incorrect. Let me go ahead and erase that. This should have been 1. Oops. Okay, so let me just erase. Okay, and then I'm going to write 1. This should have been a 1 right here. Okay, so at 0 right here, I'm only looking at x coordinates, so this is 1. And then over here at pi halves, pi halves is right here, I'm going to go to 0. So like this. And then at pi, it's going to be -1. And you can see all these values are getting more and more negative. And then over here at 3 pi halves, it's going to go to 0. So these negative values get closer and closer to 0. And then at 2 pi, it's going to be here at 1, like this. And so this is what 1 period looks like. But then it'll continue. It'll go down. And then over here at 3 pi, it's going to go to -1, 0, and then 1. And it'll have this same pattern going over here on this side. And this period is 2 pi as well. So from the top to the top, it takes 2 pi. Let's take a look at other periodic functions, like say this Ferris wheel. And this says this Ferris wheel is 100 feet in diameter, so that means its radius is 50. It has 12 passenger cars. The Ferris wheel rotates counterclockwise, takes 1 minute. The riders climb a stairway to board a platform that is 60 feet above the ground. And it's horizontal to the center of the Ferris wheel. Okay, in this scenario, the height of the car is the distance between the car and the platform. We view this as the platform, the right in the middle of the Ferris wheel. Okay, so let's take a look at this car right here. This car, you can see, is sitting right here on the platform. So our first point is 0. Okay, at our angle of 0, that the height of this car is at 0. Now at pi halves, the height of it is 50 feet. So at pi halves right here, it is at 50 feet. So the car will, on the merry-go-round, keep going up, or the Ferris wheel. And then over here at pi, the car is right here at the level of the platform, and so it'll go down to here. And then at 3 pi halves, it is going to be -50 from the platform, so it's down here. And then at 2 pi, it's going to go up. And you can see then it'll continue to do the same thing here as well. And so we say this period is 2 pi. Now let's talk about the co-height. The co-height is what's the distance to the vertical part of the platform. Okay, and again, this car is 50 feet from the vertical part of the platform, so it's right here. And so it's 50 feet, and as it goes to pi halves, it's going to be 0 distance from the vertical. And then over here at pi halves, it's going to be 50 feet, but in the other direction. So it's going to be down here. And then at 3 pi halves right here, it's going to be hitting this vertical part right here. And then at pi halves, it's going to be 50 feet right here. And then we can continue doing the same kind of thing right here. And so the Ferris wheel has to make this. And this is going to be a period of 2 pi. Now, what happens if we just look at the height and co-height, but this time we're looking at the ground, which is the center is 60 feet. So this center right here is 60 feet from the ground. So this thing right here is 60 feet. Okay, and so we'll look at this car right here at first, and you can see that from the ground, this car is 60 feet above the ground. So this is at 0 degrees, or 0 radians, I should say. Not 0 degrees, but 0 radians. And then if I look at pi halves, you can see that it's going to be 60 feet plus another 50 feet, so that it's going to be 110, 70, 80, 90, 10, 110. So it'll be right up here. So the car will continue to go up. And then over here at pi, it's going to be 60 feet again. Oops, I didn't follow that very well. Okay, so here at pi halves, it's supposed to be 70, 80, 90, 100, okay, 110 right here. So at pi halves, then at pi, it's going to be 60 feet above the ground. And then at 3 pi halves, it doesn't ever hit the ground because it's going to miss the ground. It's going to go down to 10 at 3 pi halves. And then at 2 pi, it's going to be 60 feet above the ground. So this is a little different than when we were looking right here along the middle of the platform. We're looking here at the ground, and you can see that the curve is a little different. And the co-height, how far is it away from this? Well, it is going to be the same as what we did before. So the distance from this car to here will be, again, 50 feet. From this car is 50 feet from here at 0, but at pi halves, it's at 0. So it's going to be here at 0. And then at pi, right over here, it's going to be negative 50. So this is the same graph I just did a few minutes ago. And at 3 pi halves, it's going to be at 0. So really, there was no change to the co-height. The only change was in the height when we took a look at looking at from the ground.